Greetings, fellow learners from Mathlete Minds. In this video, we'll unravel the mysteries of arithmetic progression and try to understand the different formulae pertaining to it and how they are applied. But before we delve into an arithmetic progression, we need to understand the meaning of the word sequences because an arithmetic progression is also a particular type of sequence. Now, what exactly are sequences? Here I have written the first one, which of course, obvious, it's a sequence of natural numbers. So here you find that every succeeding term can be obtained by adding one to the previous one. So this is a sequence of natural numbers n. In the second one, you find that these are all multiples of 2 or they are all even numbers. So any succeeding term, like after 12, if you want to find out the next term, it will be 14, then it will be 16. And if you know the term number, this is the number 7 over here. So 7 into 2 is 14. So this is 2n, which governs this particular sequence. Here we find that these are all squares of natural numbers. That means n squared. So if we have to find out any particular term over here, you can find the square of that term number over here. For example, this is the fifth term. So if the sixth term will be 36, seventh will be 49, and so on. So in all these sequences, you notice that there is a particular defining property behind each of them, and any term can be obtained if you understand what property is there which governs it. Now here we are given a sequence an is equal to 3n plus 2. That means the nth term. N over here represents the term number. It is a general term over here. So if we take the first term, of course, we write it as a1, the second term as a2, the third term as a3. These are small subscripts over here, which represents a term number. Now 3n plus 2. So here, if I find out the first one, a1, put 1 in place of n, I'll get here 3 into 1 plus 2, that is equal to 5. The second term, a2, will be 3 into 2 plus 2, that is equal to 8. And so on, we can generate a number of terms this way, using this particular formula or particular property for this particular sequence. In this case, an is equal to 3 to the power of n. So a1 will be 3, a2 will be equal to 3 squared, a3 will be equal to 3 cubed, and so on. You can generate any number of terms in this sequence also. Now coming to an arithmetic progression, what is the rule that defines it? Here you will find that it is a sequence whereby you will find that if you subtract any preceding term from its succeeding term, you will get a difference, constant difference that is represented by small d. For example, if I take out the difference of the second term a2 minus a1, I'll get here d. Similarly, a3 minus a2 is d. That means if you go on taking out the differences of every preceding term from its succeeding term, you'll get a constant difference throughout the sequence. And that type of sequence is called an arithmetic progression. Now here we must remember that d can be positive, it can be positive, it can be negative, and it can also be 0. So all three of them are applicable for D. Now if I take the first one over here, A2 is equal to, I can write A2 is equal to A1 plus D. I can write A3 is equal to A2 plus D. That means simply if I add A1 to D to A1, I'll get the second term. I add D to A2, I'll get the third term, and so on. So if we want to generalize it, let us take, supposing I take A2 is equal to A1 plus D. Let's represent A1, the first term, with A and the common difference with D. We want to arrive at a particular general expression, so I am taking the first term as A and common difference as D. So A2 can be written as A plus D. Now A3 we were getting as A2 plus D. This was for A3. So now if I replace this A2, I'll get here A3 is equal to A plus D plus D. I've taken A plus D from here and put it away here. So we get here A plus 2D. A4 was equal to A3 plus D. So A4 can be written as, this is A plus 2D, A plus 2D plus D, that is equal to A plus 3D. This way, if you go on generating the terms, there's a particular observation that you will see over here. First term is A, second term is A plus D, third term is A plus 2D, the fourth term is A plus 3D, and this way it will continue. So here the special observation is that the coefficients of D, they are always one less than the term number. This is the term number over here 4 and the coefficient is 3. This is the term number 3 over here and the coefficient is 2. So if we write down the general expression for it, if I want to take out any but not any particular term, but generalize it and write it as an, then this will be equal to a plus n minus 1 into d, because the coefficient of d is always 1 less than the term number over here. So this is the particular expression or the general expression or the expression for the general term in an AP. And this is that expression which we are going to use to solve a number of different types of questions. Initially, we'll be taking very simple questions, and in the next video, we'll come across with more of a different level questions, for higher level questions. Now we're just gaining the concept, so we'll take a very simple question. Write an AP whose first term is 10 and the common difference is 3. So A is given as 10 and D is given as 3. So obviously the first term is 10, the second term is 10 plus 3, 13, 16 and 19 and so on. So if you have to write only a few terms, you can just go on adding and generate this particular AP. But supposing you're asked a term over here, say the 40th term or the 30th term, in that case, you'll have to take the general expression, that is an is equal to a plus n minus 1d. An is equal to a plus n minus 1 into d. So here we'll put a30 for n is equal to a is 10 plus n minus 1, that is 29, into d, that is equal to 3. So this becomes 10 plus this is 27, 3 to 6, 77. So this becomes 87. Alright, so the 38th term is 87. So it would have been a tedious method if we would have sat and added over here. So we can apply for a bigger term number, we can simply apply this formula and get the term value of the term. The next one is find the common difference and write the next two terms of the AP. Now here you notice that some of the terms of this AP are negative. Only the first term is positive. It's a decreasing AP. So the constant difference D is equal to minus 2 minus 3, that is negative 7. Sorry, negative 5. And the next two terms will be minus 12 minus 5. The next one will be minus 12 minus 5, that is minus 17. And next one will be negative 17 minus negative 5, that is equal to negative 22. So these are the next two terms of this AP. Which term of the AP minus 1, 3, 7, 11 is 95? So here which we have to find out the term number over here. So we'll write down the expression an is equal to a plus n minus 1 into d. So 95 is the value of the term. So an is 95. A is negative 1 plus n minus 1. D is 3 minus 1, that is 4. So this becomes 96 is equal to n minus 1 into 4. So this means n minus 1 is equal to 4 2's 8, 4 4 16, 24. So n is equal to 25. That means 95 is the 25th term. The next one is how many terms are there in the sequence 3, 6, 9, 12, 111. So here it's of course the same type of question, but here we have to find the number of terms, and this suggests that this is the end of the sequence. 111 is the last term over here. So 111 is the nth term or an, and we can write 111 is equal to 3 plus n minus 1 into d, that is 3. So this becomes 108 is equal to n minus 1 into 3. So this if you divide by 3, you will get over here 3 3 is 9, 3 6, 18 is equal to n minus 1. So n is equal to 37. That means there are 37 terms in this particular sequence. Next question is which term of the AP 5, 15, 25 will be 130 more than its 31st term? So here A is 5, D is 10, and we're asked to find out which term is 130 more than its 31st term. So we'll first find out 31st term. So A31 will be equal to A plus 30D. Using that expression, AN is equal to A plus N minus 1 into D. So we get over here A is 5 plus 30 into 10. So this becomes 5 plus 300. That makes it 305. Now the term is 130 more than the 31st term. So A31 plus 130 will be 305 plus 130, that is equal to 435. So now we have to find out 435 is which term number, or which term is 435. So this becomes 435 is equal to 5 plus n minus 1 into 10, or 430 is equal to n minus 1 into 10. So 43 is equal to n minus 1. So n is equal to 44. So this means there are the term number is 44, which is equal to 435. Next question is the 10th term of an AP is 52 and the 16th term is 82. Find the 32nd term and the general term. So 10th term is represented as A10 and 16th term is A16. This is equal to 52 and this is equal to 82. So A10, if we use the expression, can be written as A plus 9D is equal to 52. This will be A plus 15D is equal to 82. Now here we get two equations with two different variables. So we'll write one below the other and solve it simultaneously. So this becomes 82, equation number 2. Now subtract equation 2 from equation 1. This gets cancelled. We are left here with minus 6d is equal to 0 and this is negative 30. So d is equal to 5. So what is A? A will be equal to 52 minus 9d. That is 52 minus 45, that is equal to 7. So find the 32nd term. So A32 will be equal to A plus 31d. So this becomes equal to 7 plus 31 into 5. So 7 plus 5 once 5, this is 155, which is equal to 162. Next question is the sum of the 5th and ninth terms of an AP is 72 and the sum of the 7th and 12th term is 97. Find the AP. Sum of the 5th term, that means A5 plus A9 is equal to 72 and A7 plus A12 is equal to 97. Quite similar to the previous one. So this will be A plus 4B plus A plus 8D is equal to 72. This will be A plus 6D plus A plus 11D is equal to 97. Simplifying this, we get here 2A plus 12D is equal to 72. This will be 2A plus 17D is equal to 97. So this is again equation 1. This is equation 2. We write equation 2 below equation 1. 2A plus 17D is equal to 97. Now subtract equation 2 from equation 1. So this gets cancelled. Here we are left with minus 5D is equal to, this is 5 and negative 25. So D is equal to 5. What about A? A will be equal to, if we put the value of D in the first equation, 2A is equal to 72 minus 60. That gives us 12. So A is equal to 6. So the AP will be, the first term is 6, second term will be 11, third term will be 16, and so on. So this is the AP. Next question is 184 a term of the sequence 3, 7, 11, and so on? So here we must remember that whatever number is given, if we get a fraction as a term number for it, then that particular number is not does not belong to that particular sequence. So let us check it out. An is equal to A plus n minus 1 into D. So 184 is equal to A, that is 3, plus n minus 1 into 4. So this becomes 181 is equal to n minus 1 into 4. So this implies 181 by 4 is equal to n minus 1. So this is equal to 4 4 16, so 21, 4 5 20 is equal to n minus 1. So n is equal to 46 1 by 4. So this is a fraction, so obviously 184 is not a term of this particular sequence. How many three-digit numbers are divisible by 7? So this is another question, slightly different. Three-digit numbers. Now we know that the smallest three-digit number is 100 and the greatest three-digit number is 999. But of course 100 is not divisible and 999 is not divisible by 7. So initially we have to find out which is the first number that is divisible by 7. So if I take 100, to find that out first number, if I divide 100, I'll get here remainder is 3 over here and 0. 7 4 28, so remainder is 2. That means if I add 5 to this 100, 2 plus 5, it will become 100 and 5 over here and it will become completely divisible by 7. So the first number over here that we get is 105. Now in the case of 999, the biggest, largest number, if I divide this by 7, 717, we get a remainder 229, 7 4 28, remainder is 119, 7 2 is 14, and we get a remainder 5. So in this case, we are not going to add anything because if we add something to 5 over here, this will become a 4-digit number. So we'll remove 5 from here, we'll get here 994. So the last digit over here will be 994, which will be divisible by 7. So the biggest number, three-digit number divisible by 7 will be 994. Now, the common difference will be 7 in between all the numbers over here. So let us see how many terms are there. 994 is equal to 105 plus n minus 1 into 7. So if we subtract this, what do we get here? 994 minus 105. Alright, so this gives us 9 and this becomes 8 and this is 9 minus 1, 8. Alright, 994. 994, I've subtracted 105 from it, so this is 9, this is 8 and this is 8 is equal to n minus 1 into 7. So n minus 1, this will become equal to 889 by 7. So this becomes 717, carry over 1, 18, 7 2 is 14, and 4, 7 7 is 49, 127. So n is equal to 128. So there are 128 three-digit numbers divisible by 7 in between 100 and 999. How many numbers lie between 10 and 300 which when divided by 4 leave a remainder 3? So we have here how many numbers lie between. So here we have to take notice of this word between 10 and 300. So even if we have these numbers divisible by 4, we are not going to include them because the question says between. Divisible by which when divided by 4 leave a remainder 3. So let us take the first number now. This is a small number 10, so obviously we know that if we choose this number 10 over here, alright, it's not divisible by 10. What is the remainder that we get over here? 4 to 8, the remainder is 2. So in order to become divisible over here, alright, what will be the number which will be divisible by 10? So we simply need to add 2. So this becomes 12, the first number divisible by 4 and giving a remainder 3. Sorry, we have to get a remainder 3 over here. So if I take this is 10 over here, 4 to 8, we get a remainder 2 over here. Alright, but we have to get a remainder 3. So if I take 11, that is the next bigger number over here. 11 and divide by 4. 4 to 8, we'll get a remainder 3. So in order to get a remainder 3, we have to take the number 11 as the first number over here. This will be the first number which will give a remainder 3. It should not be completely divisible by 4. It should give us a remainder 3. So remainder 3 will come by dividing 11 by 4 and we get a remainder 3. Then if I take the last bigger number 300 over here, 300 of course will when we divide by 4 it will did not give us any remainder. 4, 5, 4, 6, 7, 28. Remainder is then this becomes 4, 5, 20 and we don't get any remainder. So it's completely divisible. But that means there must be, if we have to get a remainder of this, this is giving us no remainder. Alright, remainder must be 3. So what is the number which will give us the remainder 3? 299. If you remember Euclid's division lemma, the only remainders that we can get is 0, 1, 2 and 3. So we have to get a remainder 3. In that case, 299 is the number which will give us a remainder 3. You can check it out. If we divide by 4, 4 7 is 28, got 19, 4 4 16, and the remainder is 3. So the first number that gives us a remainder 3 is 11, and the last number that gives a remainder 3 is 299. So now next what we do is the common difference will take as 4. So 299 is equal to 11 plus n minus 1 into 4. So this becomes 288 is equal to n minus 1 into 4. So this becomes 7 and 2 is equal to n minus 1. So n is equal to 73. So there are 73 numbers in between 10 and 300 which when divided by 4 leave a remainder 3. Next one is two APs have the same common difference. The first term of one of these is 3 and that of the other is 8. What is the difference between the hundredth terms? Now we have given here two different APs. So let us take the first term of the first AP as A, and just to keep a difference, we'll take the first term of the second AP as B. This is the first AP and this is the second AP. Now the common difference is D for both of them. Now the question over here says what is the difference between the hundredth terms? The difference between the first terms is the first term of the first one is 3 and of the second one is 8. That means A is 3 over here and B is equal to 8. Now if we have to find out the hundred term over here, so we write down A 100 is equal to A plus 99D. B 100 is equal to B plus 99D. So if we take out the difference, because we are asked the difference over here, we'll get here A 100 minus B 100 is equal to A minus B. This will be cancelled. So from this we come to the conclusion that whatever difference we are asked, or whichever terms we are asked, whether it is 100 or 1000 or 50, whatever term are given over here, the difference will be the difference between the first terms of the two AP. So here it is 3 minus 8, that is equal to negative 5. So this is the important concept that you need to keep in mind over here. The difference will be the difference between the first terms only. Next one is which term of an AP 2019 is the first negative term. This is a reducing AP, and after decreasing continuously, we start getting the negative terms over here. So here the first term A is 20. Common difference D is minus 3 by 4. It's the first negative term. That means the conclusion that we can arrive at over here is an is less than 0. The first negative term, it's the first negative term, so an is less than 0. So here an can be written as a plus n minus 1 into d. This is less than 0. So a is 20 plus n minus 1 into 3 by 4, negative 3 by 4 is less than 0. So this becomes, if you open up the bracket, 20 and this will become minus 3 by 4 n plus 3 by 4 is less than 0. Taking the LCM, you get over here 80 minus 3n plus 3 is less than 0, or 83 minus 3n is less than 0. This means that 83 is less than 3n, or 3n is greater than 83, or n is greater than 3 to 6, 3 ones 3, 3 to 6, 23 over here, 3 sevens 21, 2 by 3. So we get here n is greater than 27, 2 by 3. So it must be the 28th term. So the first negative term is the 28th term in this particular AP. Hope you like the explanation of all these simple questions over here. We'll continue with this over here, this particular sequence of arithmetic progressions, and we'll go into, of course, word problems also. Hope you like the explanation. Please like, share, and subscribe to the channel. Thank you for watching.